Hello everybody and welcome back. It's MACH 2024. It's Friday, Rowan.
It's Friday, and I thank you so much for reminding me. I almost forgot what day of the week it was.
Honestly, it's like merged into one. I feel like there's a different vibe though now. Everyone's a bit like, they're flagging.
I think they've relaxed into it. I don't know. I feel like we could do this for the next year now. I don't know.
Oh, well, you can, but I think most of the people here are ready to go.
Yeah, we see some sunlight coming in through the windows, and I want to
I
see it in real life.
know. The weekend is on the horizon. It's been wonderful, though. I personally was lucky enough to go to the MTA dinner last night.
Oh, look at you.
Fabulous. I know, yeah. It was some lovely food, and it was great to see industry all together.
Yeah,
was
it?
really
I bet they sound really nice, those dinners. I've never seen one personally. Where are we?
Honestly. Right, of course. You will be invited. I think that was a hint. Right, okay, we are on at the Schunk stand and we've got a lot to show you. Lovely, lovely Marcel, who is Managing Director here in the UK, is going to take us on a tour, isn't he?
Yeah, absolutely. I can't wait. There's so much technology packed onto this little stand here. Marcel's got some demos to show us. He's got some really fantastic technology in tool holding, which I'm going to be
but
covering.
smart tool holding as well, smart tooling. In fact, it was quite interesting. We came onto the stand and I saw a product and I was reeling off some of the companies where I was like, oh, they could do with that, they could do with that. So it's quite cool, isn't it?
It is, yeah. You see all the applications here, actually, all on show together, whereas you might see them in a machine shop a little bit hidden away.
Yeah.
It's nice to see them all on show.
He's going to go a bit more technical a little bit later about the tooling and smart tooling, and I'm going to go meet Marcel. So let's go find him.
You might want to take this microphone.
Shall I steal that? I thought you were coming with me then. I've got two microphones now. Marcel, here we go.
Hello.
Are you ready? It's Friday. How are you feeling? Woohoo!
Super energetic.
I don't know whether to believe you or not.
It's been a very long show, but a fantastic show.
It has actually been brilliant. It really has. Right, okay. We've kind of teased everyone with what we're going to see. So let's start. Just briefly, for anyone who doesn't know, Schunk, who are you? What do you provide to industry?
So we are very hard to pinpoint. We've been making work holding and automation for 77 years now.
77 years.
Yeah, automation 40-ish. So we're probably one of the oldest boys in automation now. We started with jaws, then tool holders, then chucks, then vices, then grippers, 11,000 products. I'm not going to be boring you with all of them.
Oh my goodness.
We can show some of them.
We can show some of them. Well, let's begin then, because this is the heart of your business. So tell me what you've got here on display.
This is quite nice actually, because I think this consolidates Schunk in one shot.
Okay, I like that.
Because we have work holding and automation all together. So machine tending is probably where we shine the most.
Yes.
Because I think we are the only company who has total knowledge on work holding and automation.
And the automation.
So we have from end of arm to machine table, everything in between. So what you're seeing here, it's a little fake arm. So you would put a robot on your machine to machine tend.
Yes.
Very trendy, everybody wants to do it. Bit of paralysis by choice, too many ways to get there. So this is simplifying that.
Okay, I like that.
So we have a double gripper, so you load one part, you unload one part, all the pneumatics, all the brains inside a box. This connects to your robot, one airline, robot sees the component, knows what's doing, nice and easy to control. Same for the vice. You will need a pneumatic vice, a automatic work holding to make machine loading for a mill. So same here, there will be a little valve connected to your robot, you see the vice, you operate the vice, all with independent of the robot. Super simple.
I was just about to say, you just keep it very simple, don't you?
And the beautiful thing with automation is, if you're going through a CNC machine tool, you pretty much need to make a decision very early on how big, how complex that will be. With automation, it can be progressive.
Right.
You don't have to make that decision. You can start easy and small, and then up your level or complexity as you go.
Okay, so what we're seeing here is more of the basic product.
So this is the entry level for machine tending, right? And then you can start, I need a bigger gripper, a more complex gripper, a mechatronic gripper, a magnetic gripper. All of those things can be added as you go.
So what's the thing that people are put off by? And I don't mean that it's a funny question to ask. What's the most asked question?
It's how to do it. Right,
yes.
so what do I do? What do I need to do? So I think the best analogy, especially for the CNC guys, is when CNC came out.
Yes.
It was a bit scary, nobody knew how to program it, how do I do it? And now it's everybody has a CNC. Everybody knows how to use it.
It's all application specific though, isn't it,
We're on
really?
that transition now,
Yeah.
There was not a lot of standards. These standards are coming out. We're trying to make all of that nice and easy and try to lower the barriers, the friction to get into it.
I like that. Right, okay, we're going to see some demonstrations that they've got here on the
Do you want
stand.
to see that one?
We're going to do this one first, if that's okay.
Right. Oh, that's the nicest one. This is the flagship.
We'll start with the nicest one then, let's go.
So this is a
let's have look.
high level for complexity automation. What we're showing here, so traditionally people understand machine tending for lathes. Machine tending would be a robot takes a bit and puts in the chuck, takes the bit
Swap
off,
it over.
and just replacing that component loading into the chuck. That's what he's doing here.
Doing that now, yes.
With an added level for complexity. So now we just changed the end of the arm from billet handling to jaw handling, and this is the very different thing.
Right, okay, yes. It's like the whole process. What you're telling me, it's not just, you've upped it, you've upped the ante here.
And that's what we keep doing.
And why? Why are you doing this?
So automation is easier when it's not flexible. And adding the flexibility is always the difficult thing, and
Yes.
that's what we're trying to do. So one thing that we keep hearing, all right, why should I? Yes, I want to automate, but my batches are short. And I hear the automation is only good if I have very large batches.
Yes, you're dispelling that myth.
We're fixing that.
You're fixing
that. Was
that.
true.
Yeah.
That was true, right? Because if
Yeah,
you
you're
couldn't
right.
change the jaws of your chuck and your machine then would stop at 2 o'clock in the morning, you lost all that.
Mm-hmm.
So now you can change the jaws of the chuck and change the job as well as machine tend.
So really, you're basically saying it's not high volume, you're adding that variety,
Yes.
high variety
It's
in automation.
high workload with high diversity.
Yeah, I like that.
So we have customers using these, 96 different components, 70 millimeters to 250 millimeters. Same machine, same chuck, same cell.
Right, that's turning. So we need to take this now to the next level. So Marcel, follow me. We'll move slowly. Have you got two products here?
So
quite
these are
similar?
pretty much different takes of the same approach.
Okay.
So machine tending now for milling machines.
So we'll look at this one. They're very similar. So this is an example, but
yeah,
let's
so
talk about this one.
There's just a little bit more going on here, which is probably summarizes both of them. So what we're showing here is machine tending for milling, very traditional stuff. So here we have an end of arm,
Oh, look at this, yeah.
doing a little bit of a dance.
Yeah.
So this is new. This is our new mechatronic gripper, which gives you a much more versatile approach, and that's the point of this. So a very large component being taken from a mill.
Yes.
So you have a pneumatic vise inside the machine, taking that out, bringing that back in, and you're just doing that. On these end, we have a amplier, which is our grinding tool holder. So this would be in a grinding machine. Is a hydraulic expansion thing. Lovely. That's the technical term.
Product.
It's a technical expandable arbor, which will take one of those grinding things for you to put in here and polish and do the cutting edges of a drill billet, for example.
So it's all about automating the whole process.
Yes, but the beautiful, what we're trying to understand is like, can I machine tend? Yes. And what do you have to do? You have to automate all sides of things. And there will be a solution either on a grinding machine, or milling machine, or a turning machine. There will be something that will be designed for that particular application.
So if you need to automate, speak to Schunk.
Yes.
That's it.
I will summarize that even like, if you have work waiting to be done,
Yes.
talk to us.
Yeah.
Right, because it can be, automation doesn't have to look like this.
No.
This is the epitome of automation, that's what people think of it. Automation can be done manually. You
Yes.
can have a quick setup, that's automation.
Yeah.
You automated bits of the process,
Yeah.
right? So you don't, like I said, it's gradual.
It's gradual. You can build up.
You can
build with Schunk.
Quick setup,
Yeah.
then robots, then this, then that, more complexity. It's a building block process. It doesn't have to be done in one day.
Right. Well, I think someone else is going to interview you now. We're going to go talk tooling and smart tooling, and we're going to take you on a tour of the rest of the stand. Here you go, Rowan.
Thank you very much, Lindsay, passing off. So we're moving on. Thank you, Marcel. So obviously, Marcel, automation, work holding is really important, but equally as important, arguably.
Yes, I mean, this is our tradition, tool holders. What we're trying to show here is the complete range with a very nice cherry on the top there. So
absolutely.
Mechanical holders, tradition collets, collets, that kind of stuff that most people are used to. Heat shrink, we do all of that.
How come these are on kind of the basic shelf, and then what happens to a tool holder when we move up the kind of the economy?
So this is not a level of quality, it's a level of features and complexity, right? So what we're showing here, the things that we know mechanical, they are easy to implement, but they come with caveats. Runouts are never as good as hydraulics, which is really where we shine.
Absolutely.
So the hydraulic range will have very low runouts, 3 millimeters.
3 microns is quite a lot. 3 microns.
3 microns. And what does that mean? That the vibration will go down. Life of the carbide will go through the roof. But mainly the quality of the work will be improved.
Absolutely, absolutely. When you bring the runout all the way down, there's huge knock-on benefits. But I guess when you go to from an ER collet, there's also other situations where with a hydraulic, even pressure is good for a runout.
So one thing that it's an extra benefit of the hydraulics, they are very easy for you to set up, we know that. The runout is fantastic. But how do they work? You have a little oil chamber inside here that you press with a little Allen key, and that expands the inner bore. That oil chamber will work as a vibration dampening system, and that brings even lower vibrations into the process. Longer spindle life on your machine, longer life. So if you are cutting with carbide, these will be free very quick for you.
Yeah.
Because the life of the carbide will be brought to a point that this will have a 6 months return of investment for sure. For sure.
Yeah,
and that is if you don't use high-level carbide. And then this is the new stuff. This particular guy here is the new stuff. So this is a hydraulic, quite unique. It's a hydraulic holder with a shrink profile. So these you can introduce hydraulic where before you had to go shrink, like for like, you don't have to reset your machine. You just take one, replace, put another one, and you're gonna get all the improvements of the hydraulic body, the technology, the easiness, without...
But for the exact same profile, you don't have to change the process.
Yeah, exactly.
And we're gonna see, this is something quite new for Schunk.
That's new, this is in development. We are now version 2 of a long timeline. We don't even target this in sales, we target this in application. We're very proud of this. I think we can actually show it.
Yeah, we're going to be showing a demo of this. This is a smart tool holder.
So this is a smart tool holder.
Let's go have a look at the demonstration.
So what we're looking at here, they come in all shapes and forms. So this one is the Slim 4X, which is the heat shrink replacement. The profile in itself, it's not the most important thing. Inside here, we have an accelerometer. And that thing is linked by a Bluetooth.
An accelerometer will measure the kind of displacement and the acceleration inside any object you attach it to.
So this is not new. People know this from spindles. They are measuring vibration in spindles for a long time. That comes with some caveats. It's a big lump of metal. Which brings noise into the measurement.
Yeah, when you've got a big spindle assembly rotating, there's a lot going on there. A lot of bearings, a lot of drives.
And your sensors will be measuring all of that. So it's like going from naked eye to a microscope. Now you're measuring what's happening at the tool level, right? So this is live, and as I give it a bit of a nudge,
you can see the vibration level is increasing. And now you're using a value called the chatter index.
So
how's that calculated?
This is a simplification of what's going on in here. So what you're seeing here is just 15 hertz, just so you can make sense of it. But it's picking up 1500 hertz. So every second, 1,500 readings are happening in here. And then we oversimplify for you here. Then you export their raw data into your system, and then you do the analytics of what you're trying to do. We have one customer, for example, trying this to see if they can go from virgin aluminium to recycled aluminium and see how the tools behave. Is this okay? So there can be massive savings in material costs. And they're using this as a measure. So this is actually tool holders gone metrology. This is a metric tool now. You can use this to see what's happening with your process.
Absolutely. And you're targeting this mostly at process development, not in production.
So this, exactly that. So there will be a next level for this. So now, this is for the R&D, the developing guys, the process guys. So when you have a high complex component, a high level component that you want to optimize the strategy, this is the kind of thing you're going to be using for it.
Okay, fascinating. And we're going to be seeing this hopefully used more in machine shops. If someone's interested in this kind of technology, what kind of problems would they be having that then they would maybe take this on to try and solve?
So this is used for, funny, we designed this for these high complex aviation components, and now we have customers using this to check the health of their spindle.
Yeah, so there's new applications that you might
Our
you guys
customers
might
are
not be
helping,
thinking about.
and like I said, we're not targeting sales, we're targeting applications. We want to work with our customers to see this in place and develop the future of these.
Brilliant. So if you want to get involved, try and find a new application for tool holder with an accelerometer in it, measuring vibration in cut, which is obviously a really big, important component of maximizing your process productivity.
It does have a little brother if you want to use that on your work holding.
Oh, okay, so you could screw this to a vise.
So this can be next
any
to
kind
your
of
work
0
holding
point.
or anywhere where vibration might be causing problems. You do have a little fella.
Absolutely, and we're going to have a quick look at an aluminium component here. And on aluminium components like this, you might end up having vibration not at the cutting edge, but in the workpiece itself because of thin walls, because of incorrect clamping. Here we've got some fantastic clamping here for a
Right, so
component like this, right?
this has been the start of the show. It's been on the works for a long time. The very final stages were tested at the MRC, so this has a bit of a British blood in itself.
Yeah, good heritage.
Very good heritage. What this is a, how can I summarize it? A compliance unit for machining highly complex components where stress is a problem.
So we're looking at like an airframe component here.
So this would be the inside of a wing in scale. So this is a much smaller version of
like
what you
a
would
rib.
see. Exactly. So this is the rib inside the wings. You would see many of these, or not many, but some of these. And everybody who works with this kind of component knows that you come from a very large slab of aluminium.
Big square billet, there's loads of material to take out when you're roughing out these pockets.
Yes, and the manufacturing of the raw billet has inherited stresses into the part. So when you cut, this thing will bend. And traditionally, you cut, it bends, you flip, and you flip, and you flip.
Because when you cut it, you then release the clamps that were holding it in place, and those stresses
And
release
those stresses
themselves.
will just, yeah, exactly. So the part would then just go up and down and twist and turn in all its forms. And then to avoid that, so not to avoid that, you can't avoid that, but to address that, you keep flipping the parts.
So someone will come in and they pull the part up, flip
Release
it over.
the whole clamps, which might not be in a small, quick setup. So you're going to release the whole thing, flip it, clamp it again.
And continue the process, keep
and
roughing,
keep doing this,
semi-finishing.
So what we're trying to show here, that this can be avoided by using this. So what it is quick setup on the top, but the magic happens in here. So when I open this, and we have a demo here, all of it can float in all axes.
What you say called compliance is a huge amount of
Exactly.
movement.
So we have
radially
6 millimeters,
and
which in
in
this
Z.
world is miles.
Yeah, so that material can move.
The way you would do, you cut, this thing will be tense, will be stressed. You press that, it releases, so it's been locked.
So every single one of these is
Absolutely
released.
rock solid, it's locked. You cut, stress is built in, you release it, it goes to its position, you clamp again, you don't flip it now, and you just carry on with the cutting.
But you would maintain a certain datum point.
So
here
it always
and
has a
here.
datum in some part of these will be designed and help you in this process. Datum, diamond, and floating.
Wow.
So you always know where that is. And massive savings in cycle times.
Yeah. So that's instead of someone coming in and intervening, and this could be fully automated in theory. You could have an automated
This will
process
hopefully
making
you
this
integrate
from a
that into a
billet.
machine, and the machine will be controlling that for you.
As a testament to Schunk's dedication to super high technology, this is not going to be used at a small subcontractor around the corner, but here in Birmingham, this is a big aerospace application that traditionally would only be commercially viable if someone was going to be manually handling this component.
Yeah, exactly that. So it starts from components that are 1.5 meters long and so on.
Brilliant. So that's dedication to the aerospace industry as well, trying to automate.
Yeah.
Which other products would you like to cover
So
here?
we can talk a little bit about like a simplified version, more realistic, more down to the earth.
Okay, here this is what you might see at any subcontractor up and down the country.
Some people might be familiar, some people still not familiar with 0 points. What is 0 points? It's just a quick way to change the jobs, a quick setup system. So 0 points will have a little pin in the back of your work holding and a pot like so. And in this case, we have some motion rotation, and this guy in particular has air through the body. So when, again, automation is becoming very present, you will need some pneumatic device on top of that. So now you can just feed the air to this guy, and through it, we can now control a pneumatic vice. So change the job takes as long as that, single-handed, right? 5 microns repeatability.
I love that you can do this demo with a microphone in hand as well. I'm sure most machinists don't, but they could do if they wanted to.
So now, we have an operating vice, nice and easy.
So you can control the 0 point and the vice through,
Exactly.
almost like coming from rotary table background, it's like a rotary joint, but it's a static joint,
Exactly,
it's a pneumatic joint.
So, and this vice, which is also new, has a nice little feature, which it's an ultra-fast jaw-changing system.
Wow, and that's all pneumatically activated as well.
That's all on the system, and it can be as easy as that.
And this is where pneumatically actuated vices, which would traditionally not be used in quick changeover environments, more in an automated environment, making lots of volume.
So this is a little bit of both.
Yeah.
Right? So this is the beginning of the future for what we saw with the chucks, auto-changing jaws. So this is, we are changing, so you have an automated vice, you have a robot loading the components, and you need to change the job. You can either palletize that at a certain cost, which we can do that for you, or you can reduce the cost now, having a hybrid solution where a human being can change the job very quickly and reset, but in the very near future, a robot will be doing this as well for you.
You're only investing in a limited number of these items. You can then make soft jaws and change those out automatically for lower batches.
Exactly that.
Yeah, it's wonderful seeing a move in automation towards a kind of high mix, low volume.
And again, we were talking this with Liz earlier.
Lindsay? What's short for Lindsay? Liz?
Can you hire Liz now, please?
I've been called worse.
So, when we said that automation doesn't have to look like a robot, this is automation.
Yeah.
By just doing this, you automated all that clamping process.
And someone's not going to be there with a torque wrench, a set of Allen keys, even searching for the Allen keys somewhere down the workshop.
The automation has to look like a humanoid. Automation
Some
is
big
just
arm
making
going,
something quickly on your behalf.
Absolutely, absolutely.
You know.
So eliminating all the tools in the process as well, without needing a robot, you can automate with Schunk today.
Yes, exactly.
Absolutely.
And now, on the automation side of things, for these to operate, you need to have air through your machine, which is becoming very common. But we still have to deal with lots of legacy machines. So we have a solution for that. So I asked this question on the podcast to you.
You did, and I gave a very bad answer. Very bad answer.
It wasn't a bad answer. I just want to have automation done by you because it's cheap.
Yeah, I don't charge much.
So retrofitting air through a machine table can be quite expensive and quite difficult, and sometimes not even possible. So what we've done here, you wouldn't do this by choice. If you're going new, go air to the table, do that. We have a legacy machine that you want to bring into the equation now. So you don't have air feeding that pneumatic vice. It's not going through your machine. What do? So you have a robot, which is what this is simulating. Robot is coming in. Robot will then dock with a valve on its wrist, another valve on the work hold, and as the robot docks, it operates the device for you.
Oh, so you don't
so it will dock, lock, and move away.
You almost have a floating air source that you can then dock in.
The air is locked in here.
Wow.
And it keeps it energized for as long as you need. And when it's ready, it comes and
This
picks.
is like Starship Enterprise. Do you know what I mean? Watching this coming in and docking, you've got a floating air source you can put anywhere down around the machine tool.
This is the kind of thing that is just a small little component. I'm very proud of this because this is cheap, right? On the face of it, it's really cheap. And it makes something marvelous possible where you would have to change the machine, retrofit, done.
Absolutely. You can imagine people with machine tools that have been running processes for years.
Lots of legacy machines out there that might need.
They just want to automate.
It's not even, they want to change the process, but they can't because the machine will not allow them to do it.
Absolutely.
And that this will do it.
Brilliant. So, thank you very much, Marcel. That's fantastic. I'll give you a handshake and take the microphone off you, if that's okay.
Marcel, you put the products in people's lives so well, don't you?
Thank you.
You can tell your passion.
I do try.
He does, doesn't he? He really puts the product, you're like, they could just do this and it's just as simple as this, and it makes it so easy to understand. Thank you.
I hope so. All right.
Yeah,
Thank you,
brilliant. No, thank you.
All right.
Thank you for letting us have a tour of your stand.
Thank you, Liz.
It's all right. So my new name is Liz Vickers now.
That's something you're not going to escape from, I don't think.
No. That was really interesting. I love seeing him give the demos, and for me, what I learned from that is the fact that automation is not now just about the billet and moving that around. It's about taking it to the next level and integrating it with obviously your the jaws and everything.
The jaws
the
and the
process.
chuck, yeah, absolutely. Trying to automate as many different parts of the machine tool so the human can do less and less, and it applies to more machine tool shops that are doing more high mix stuff, less volume.
And actually, it's addressing what's happening in industry now about a skills shortage. So people are actually trying to find solutions to what is happening in real life today.
Absolutely.
How are you feeling?
Good. I'm feeling good.
He's feeling
I'm
great.
I'm glad we've covered Schunk in that much detail. I'm
it's
so
brilliant.
happy.
Oh,
I'm so
I
happy
hope
we
you've
managed to get
enjoyed
through
it.
this.
Yeah, definitely. Thank you, Rowan. Right, okay. It's not finished. It's not the end because we've got a podcast at 2, don't we?
We do. Podcast, we've got some fantastic guests lined up to round off the MACH show,
We
which
have.
has been a wonderful week, but it's...
And I think we're going to chat about what we've learned too, and there's some people that there's a lad, hopefully we get him on, and I met him 6 years ago or something, and I'm really excited about interviewing him 6 years on now as well, so
Absolutely.
stay tuned.